Okay, since I'm just sitting here doing nothing, I'll take some notes too.
Okay,
Oh,
thank
okay.
you.
Thank you.
Oh, double
Thank you, Harold.
volunteering. Wonderful. Thank you. All right. We'll give a few more minutes for people to get back from lunch and or find their way here in whatever time zone they're forced to be in. Just midnight for me. Let's see. What did we make our agenda? But I think we're fairly full, and we usually are not very good at keeping to time. So probably we should try to get started. So hello, everybody. Welcome to AVT Core at IETF Yokohama. I am co-chair Jonathan Lennox. Bernardo Boba is also here, and Harold Alvestrand has both volunteered to sit at the front so people can, to reassure people that this is a real meeting, and also to take notes. So thank you, Harold, for both of those things. This session is being recorded. If you're in the room, please be sure to join the session using the Medico client, either from the agenda or I believe there should be a QR code somewhere there in the room. If you want to speak at the mic, please join the mic queue using the tool. If you're using the full version, which you might do if you want to see the slides closer up, then please make sure to keep your own audio and video off if you're in the room, and also your audio playback so we don't get feedback in the room. And please remember to wear your masks unless you're actively speaking at the microphone. Remote participants, please keep your audio and video off unless you're chairing or presenting. Use of a headset is strongly recommended to avoid feedback and other such annoying things. Remote meeting tips, although I guess the enter the queue is true for everybody. There's a hand tool under your name at the upper left if you're on a laptop. Enter the queue with icons seen there. And you're called on, you'll need to enable your audio. You can also enable your video if you like. It's separate from audio. It's encouraged because it can help to understand you, but it is not required. The important thing is that we can hear you. Here's various links, which if you actually go to the slides from the data tracker, you can see the real thing. Hopefully there are no issues. Note well, please, hopefully if you're here, you've had to see this at least once before, either to register in person or to join online. But there are various IPR policies and codes of conduct policies that please everybody should be aware of and adhere to. As usual, particularly the code of conduct, everybody is expected to be professional and respectful to everybody else. And if hopefully nobody's had any problems with that, but if you have any problems, please contact either the chairs or one of the IETF ombudspersons. IETF mask policy, if you're in person, please, masks can be removed briefly for eating and drinking, and when you're speaking at the mic, but please keep them on otherwise. About the meeting, note taker, here are the various links for various things. On-site, Harold will be performing any on-site duties needed for mostly in-site technical, and to reassure people they're in the right place. So yes, you're in the right place. You'll also be taking notes, so thank you, Harold, for both those things yet again. And here's the agenda. I'll be starting with some review of the RDP failout for skips, some issues that came up in ISG review, then the EVC payload format, the volumetric video coding payload format. Hopefully all those will be relatively quick. And then ironically, RTP over quick, which will not be quick. Then some proposals for some RTP messages to decode your energy reduction. And finally, RTP payload format for S-frame, which does not yet have a draft other than S-frame itself, but Peter will be talking about what we're proposing to do for S-frame over RTP. And then finally, any next steps. So let's see. Draft status. We got some things published. Just to briefly, with a different hat, to toot my own horn, I actually have Cryptex in production for Jitsy's backend server-to-server communications. So that's very exciting.
Cool. Is there anything you've interoperated with, or it's just
no,
you?
just ourselves. But because as far as I know, nobody else has implemented it yet. I was hoping, I think at some point somebody was thinking of doing a hackathon to get it into the browsers, but I think they got too busy. But I'm pretty sure our code would work with a browser if a browser implemented it. So I would encourage browsers to implement it. VP9 is still in misref. 7983 BIS has been approved, announcement to be sent, IETF follow-up. Skip has several discusses, which we'll be discussing in more detail. And frame marking, the status changed about several hours ago. It looks like Mo finally published the updated ID, so that's exciting. So that's back in the hands of our AD again. And hopefully that addressed all the issues that came up. Is our AD in the room? I can't tell. I don't think so. But hopefully that will be taken care of. I know thanks to the art AD is extra overloaded because Francesca is on maternity leave, so that might be slower, but hopefully we'll get that done. And that would be exciting, especially because I believe that would block the misref on VP9. Apparently I'm coming through a bit loudly. Let's see what I can do about that. I don't know. Maybe I'll talk a little more quietly. Is this better? All right. So we've adopted several drafts, RTP over quick, EVC, green metadata, and V3C. Some of those we'll be talking about today. And next up is RTP for quick. So Dan, are you presenting? Looks like you are.
Here I am. Good evening, good morning, good afternoon, wherever. Yeah, we're here to discuss what we've done to move forward with our document discussions last month at the virtual meeting. If you want to go to the first slide, we can start with that. Again, trying to restating our focus that this document is really designed for network devices. Again, we updated the abstract, the introduction, the media format, payload sections to try to make the focus more towards the network devices, because our primary purpose here is to get skip through the network. That's really what our goal is here. The skip protocol is all defined in the skip 210 specifications and other skip documents. So that's really not the focus here. Again, we've tried to gone down the road of trying to, or people have requested details about the actual payload format, which is really difficult to do because of the way the skip protocol works. It's as we've talked before, it's not a particular format like G711 or whatever that's a real easily identified format for the payload. So again, we've tried to move it back up a layer, if you will, to try to say, well, we can't really define that protocol, the payload format per se, and identify as networks to just let it go. Again, we added a figure to section 4 to illustrate how skip payloads are packetized. I know that was a comment from reviewers discussing how skip is formatted. So and packetized and MTU size and all those type of things, and provided a basic notional concept that each of the individual codecs, whether we're running G729 or MELP or some of these others, they already handle that. I mean, those payload formats are small, so it's really not an issue to have to avoid fragmentation for that. When it comes to like H.264, it already handles that, and or it's already discussed rather in the RFCs of how to do that, how to break that format, setting the marker bit, things like that, to how to break up the packet to fit within the MTU size. So skip itself, the skip control messages have overall packet lengths, message lengths, so they can easily be split amongst packets and reassembled on reassembled on the far end. So that's already part of the skip protocol. Again, it was originally on circuit switch network, so that was already inherent to the protocol itself to have packet lengths, message lengths rather, to handle that. So there really wasn't more to be discussed about that, other than saying that that's how it is. So and our biggest catch, or biggest emphasis that we try to put, I know we talked last time about filtering and deep packet inspection and all that. We decided, because it's really impossible really for someone to try to come up with a profile or packet filter for that. So we explicitly stated in the document to say that network devices must not filter skip packets, just because there's really no way to come up with a exhaustive way of trying to figure out what's going on at any state and time. Plus, with the traffic being encrypted, it's impossible to figure out what's going on with that. So so that's what we changed with that. I don't know, we missed the deadline for submitting it prior to this meeting. We look forward to getting that out right after this meeting. If there are any other comments or questions that we need to address with that, we can certainly go make those final edits and get this document out real soon.
Yeah,
So,
the submission queue is open now. If you, but once you're ready, you can submit it. It reopens.
yeah, I was just holding off just in case there was anything that came up during this meeting that needed to be changed.
right.
So do that. So, and final slide again is, again, well, next slide actually is the document, is the figure that we added to the, if you want to go back one, sorry. This we reference the figure that we put in there to explain how skip is packetized before going out through the RTP layer. So that's basically the figure that we added with that.
I'm hoping this figure will answer most of the questions that you got, at least from Roman, I think. I think it answers them, but we'll see, obviously. Yeah, Roman's here. What do you think, Roman?
Hi, Roman Janito, I guess the holder of the discuss that you're making some of the changes on. So thanks so much for kind of all that iteration, kind of, Dan. Part of it is I haven't read the 06 that's somewhere on the mailing list, so I'm not sure. I'm still a little confused. As I dropped an email earlier kind of today, we're describing a payload format, right? So we're saying you will encounter on the wire this RTP thing. It will have a blob. You don't need to worry about the blob, but we're going to tell you about treatment about RTP. I don't understand how you can not normatively cite the fact that there's a blob and the blob is called kind of skit. And then you can, in your security considerations, do pointers to that normative reference of, hey, there's all sorts of other kind of security properties like that encryption and potentially implications on that packetization via reference. Is the new draft kind of addressing that in some way?
Like I said, we kind of pulled back. Like I said, we try to pull back on trying to define exactly what is on the wire at any point in time, because like we said, a lot of it's opaque because it's encrypted. So you can't, it's encrypted payload, for example, a H.264 stream or a G711 or G729 stream. So you really can't, per se, that plus along with all the control messages that Skip has to try to define a particular RTP payload format at one particular point in time. So we kind of try to pull back away from that rather than trying to describe all that in this document.
Well, Dan, also, aren't the control messages themselves encrypted once the keys are pushed down?
Yes, the control messages can be encrypted as well. So those are not, again, those are not plain text messages that, that's, a network device could filter on, because that's, those would also be opaque. So I mean, go ahead.
I'm happy to wait for the 06 draft. I'll confess, I still don't understand, because we're describing, it seems like normative behavior to do filtering, not filtering, and guidance, but we have not yet normatively stated what the blob is.
Yeah.
That's-
So we originally said because of the, somewhat difficult issue with accessing the skip specification, we decided to cite it, informatively. If we did move that to a normative reference, would that difficulty of, only accessible, not a publicly accessible specification, but only accessible to those requesting
Well, but
it, would that be an issue for the IESG, do you think? Because we could certainly,
even if it was,
obviously.
Yeah, even if it was normative, though, the blob is still encrypted. It's not, there's nothing that.
Yeah, but it's
blob.
But yeah, I mean, it's encrypted, but it does, it does mean that, on the theory that lets implementers know, in theory, what to do. So Roman, would moving that back to normative cause any other problems? Is my question, given the issue with the accessibility of the specification.
That's a tricky question. I can't answer that question, because one would think that if you make a change like that, that's a consensus check, and I can't speak for what the IETF community will feel about that, or how my ISG kind of peers will feel about that. But in terms of addressing kind of the substance of some of my discussions, like where do you find that information, it would certainly smooth many of those over.
yeah, I mean, the thing is, the diagram here just kind of describes what's happening, in that by the time it gets to RTP, actually, I think maybe it's a little confusing, Dan. You have this right-hand arrow which goes from the packetizer to RTP. I guess that would be the stuff that comes through before key management completes.
Right. There are some control messages that are not encrypted. So
that are not encrypted,
whereas
right?
others
So
are. So
right, and
yeah.
once the state machine goes to crypto, then everything passes through. So that's it all comes out as kind of an opaque blob that's put into the packet according to the MCU size, because there's nothing else to really say about it.
Right.
Yeah, I mean, to be clear, I personally, at least, am not interested in seeing a tremendous number of really any details of unpacking what's in skip. My only point is, this document, as I understood it, is the payload format for kind of RTP, and back to completely accept it's a blob getting put in there. My point is that blob has properties, and what is that blob? And if you're not willing to write it up in this document, and it probably doesn't make sense to do that, one typically would normatively reference and say, we're not going to tell you what it is. Here is the reference to find out more about that blob. That's what makes it, to me, an RTP payload document.
Yeah. Are you just interested in like the security properties? I mean, the fact that it's authenticated and encrypted and all that, or
I think it's just a matter of, whether the reference is considered normative or not. It's
okay.
Yeah, I'm sorry, I can't tell who's speaking kind of with the way Medak was doing it. So I think it's Jonathan. Yeah, I think that's exactly right. I mean, there are security properties. We don't need to go in details. It probably would make sense to summarize them, but after you summarize them, you can say all the details are someplace else. And I think that gives you the cover that's needed. As to whether that's all okay with the community based on how easy or hard it is to get that reference, I can't canonically answer that.
Mike, I see you next in the queue.
Hi. Yeah, as a co-author to this, in the part that you're paying attention to a lot is what is in this RTP stream, and what is in there is very variable and undefinable, and actually still evolving. There will be changes to what is in there going on later this year, next year, year after. We have to be careful that what we put in there is what in description in this is exact. RTP payload format is variable. It'll be dropped down out of the SCIP application, a different layer who's running some form of codec, audio, video, data even, and it's just going to be put down into the RTP stream for transport. The problem, if you read the intros and background in the RFC closely, you understand that the problem we're having and why we are here is that as security appliances have gotten smarter, they only are interested in letting known payload types pass. SCIP, as pointed out many times in this presentations we've been doing for over a year, is not that well known, and isn't partially because the documents are sort of in a controlled environment. And we need to get the message out there that SCIP is a legitimate thing on your network. And you can take RTP out of this diagram. You could put in ISDN, you could put in circuit switch data, you can go over SONET ATM, and it would still work. So the payload type is variable, and it will continue to be variable, and it will evolve.
That part of it isn't unusual, Mike, because basically, with the ITU-T codecs, the similar thing happens, right? They get revised. It's not under the IETF's control. So that part I think is not unusual at all. If you're worried about that, that happens all the time, unless a change to SCIP requires something in the RTP format. I mean, there's nothing that you need to come back for. SCIP version 2 or 3, it doesn't really impact the RTP format.
Yes, and that's exactly the point. We don't want to have to go back and ever change this. The SCIP RFC is meant to get our SCIP codec /8000 SCIP /90000 through a network, and the what is in there should not be important to any of the network routers, session border controllers that are passing this traffic through.
Yeah, I mean, later in this session, we're going to be talking about a totally different end-to-end encryption scheme. And the irony is a lot of what you've just described applies to that one as well, even if it isn't SCIP. So.
Yeah, I realize there's a big tendency to want to take something defined as RTP format of some transport and say, well, you're going to tell me exactly what's in there. We can't. It's not that we're hiding anything. It's the fact it isn't there.
Well, I mean, basically, so the point is, I think the point is not, argument is not to say in this document what's in there, but just simply to say, I mean, it's simply a matter of, this difference in a normative versus informative reference. The fact that to understand, I think Roman's argument is that to understand what this actually means, you have to know, SCIP is, SCIP defines what's inside these packets, and that's entirely SCIP's business. But it is, if you actually, if
may I interrupt this conversation very quickly? I have just one point to make, and that is normally I mean, for Roman's benefit, we had been back and forth regarding this question of normative versus informative with all the hurdles like 1,000 times here in the working group, right? This has been discussed ad nauseam, and what made the working group at the end accept the idea of using an informative reference was that classic hurdle is reading of the skip spec necessary to implement this specification which we are discussing here. And the answer to that question is no, it is not, because of this whole blob thing. You know, it's not necessary. The only reason why it is referenced now is because they have to give that thing a name for the reason why they came to us in the first place, and that is this media type registration, right? But other than that,
Correct.
it's not necessary. You can implement that spec without knowing what skip is, and that should be really the criteria. I would hope. Thank you.
Just wanted to follow up on that, Stefan. It may be confusing to the ISG because, for example, in the case of the BBC RTP payload, the BBC spec was normative, but that was because it had structure, right? So there was something you could do with it and talk about it. And the difference here is it doesn't because it's encrypted. And I have read those skip documents. They were made available to me. It was interesting to me to read them, but at the end of the day, there wasn't anything in there that now hasn't been put in, I think, that was relevant to the RTP payload format. You know, after I read it all, it made more sense to me, but essentially, to write the packetizer, you're just being given these blobs, and they're, the MTU is already, you pass down the MTU, so the blobs come with the appropriate MTU size, you just shove it in the payload. I think that's accurate, Mike and Dan, right? That's basically all you have to do as a packetizer, which is what we're talking about here.
Right. I mean,
Yes.
right. Yes. I mean, like I said, the codecs have their own, RFC to deal with that, how to packetize it if it is bigger than the MTU size, and
So if you were
skip
to
itself.
look at the code of the packetizer, it's not parsing anything. It's not like most packetizers, they do parse the codec. This one isn't, because there's nothing to parse.
Correct.
Correct.
Anyway, I'm not sure if we've given you the guidance you were looking for, Dan and Mike, but I think probably the right thing to do is to submit your draft, and we might have more discussions and see where we go from there. I'm not sure. Does anybody else have any comment or advice?
I think it's important to reread the narrative sections. In particular, the beginning into the RTP format section 3, where we try and re-emphasize that there is history in having a codec like this, something where the RTP stream is really undefinable in a sense of to any benefit to any network device, and that was RFC 4040, where they make no attempt to even discuss what that clear channel is used for. It is just a clear channel that is an RTP channel.
And
no mention at all.
If you stay to the end of the meeting, Mike and Dan, I think you'll hear this point come up again and again in the presentation Peter Thatcher was about to make, which is really very, very similar, because he's also doing end-to-end encryption, and the payloads that go to the packetizer are opaque. So,
right.
Yeah, I think if you're looking for guidance from us, I don't know, Jonathan, if you have any guidance, but you submit the document as Jonathan said, get it in the draft, and there may.
Yeah, I'd say so. Yeah, I would say I agree. So submit the document and let the IESG review, and we can decide where to go forward from there. We can probably continue this by email.
You may see some discusses will be cleared, others may not, and you can come back and we'll try to figure out it from there. But I think that's the guidance.
Okay. Thank you.
Thank you.
All right. Thank you. And now EVC, who's presenting this one? Stefan, are you doing it?
Me? Yeah,
Okay.
I will do that. Stefan Wenger, RTP payload format for essential video coding. MPEG 5 essential video coding. Next slide, please. Thank you. So the real reason why we have asked for our time slot here is to just remind people that that thing is still around. The original individual draft were submitted in late 2020, and then we had the working group draft in 21, and then it sat dormant for 2 years. And the reason why it sat dormant for 2 years was because we had a working group agreement that we EVC authors asked for ourselves, to basically let that thing sit until we have learned the newest lessons, how to get this week an RTP payload format through the ISG, which changes over time, especially with respect to the security and to the congestion control part of the story, and also to the media type registration. So fashions changed there. All of our own experience was a decade old or so. So we wanted to go through this stuff only once and not twice. So and the VVC payload format is a good guiding stick here, because it is VVC as a codec is it's not quite a superset, but from the functionality to the point where an RTP payload format author would care about, it is in practice a superset of VVC. You remove the spatial scalability, and you basically have most of the bitstream structures of EVC. So we were thinking, let's wait for VVC to be done. Then VVC was done. At that point, we went and fixed our English. Not one of us authors is an English native speaker. Fixed our English based on the feedback from the RC editor on the VVC payload format, added the media type, and so on and so forth. Did some work and sent that out as number 3 and number 2, and then immediately after that, number 3, February and March 2023. And the 03 normative content is complete, and we think, and ready for working group last call as a minimum. We have identified the need to do an 04 because there are some editorial issues. We gave this document to a few people to read, who are, one is the editor of the EVC specification itself. So people who really know what they are doing in this field, and they came up with some stuff where, there's room for improvement in the characterization of the EVC code and stuff like that. But when it comes to the bits on the wire, version 3 that was distributed like 2 weeks before the cutoff deadline is complete and is ready. So we have a working copy of 04 ready and can submit that as soon as we should. That's what we ask for. When is the right time? We have a media review email message drafted that's ready to be sent. It's in my draft folder. We don't have really open questions except to ask for guidance how to proceed. So we will request working group last call on this number 4 revision. Next slide, please. Thank you. There's just a little change log here since 01, so since the version that we did back in 2021. again, largely based on the lessons we learned with the VVC payload format. We were able to throw out quite a bit of text in the offer answer section and in the media type registration, which has a lot to do with the lack of spatial scalability and the surrounding a little bit tricky functionality that the VVC draft needs to support and this one doesn't. Then we looked into other things that we learned from 9328. So congestion control and security are basically copies. And that's justifiable because those particular features of the codecs that are relevant in this field are the same. The feedback message support there, we removed slice loss and reference picture selection indications. That was also removed in the VVC draft based on at least our observation that no one's using these things anymore. If anyone has a different opinion, tell us. We can put them in. It's not difficult to do, but in the interest of keeping the document halfway manageable, we rather remove things. Many editorial updates were lifted from 9328. And then there is, the changes in the packetization rules are also simplifications that result mostly from EVC's lack of spatial support. So these are the two slides I have. Let's structure this as follows. Is here anyone who sees a need for SLI or RPSI? Doesn't sound like it, right? Okay, let's skip that. And we could submit version 4 like tomorrow or so. And would you guys be willing to issue a working group last call on it?
Sure.
Yeah, I'd say if the authors think it's complete, that's when you should do working group last call. So, yeah,
it's complete, and there are no normative changes relative to version 3 that was out for like 2 weeks before the IETF cut-off deadline.
Yes, that seems better. Yeah, get the 4 published if you think the descriptions are better. Just, and then we'll do a work last call sometime after people are home, I think.
Mm-hmm. Have you guys already decided who will shepherd that thing?
It'll be me,
no.
probably.
Okay, I'm happy with that.
I'm willing to volunteer since I did VVC. So.
Thank you, Bernard. This is excellent. That will make my life or our life really, really easy, I think. Should I once we've published, once we've sent out the updated draft, should I get also out the media type review already, or wait for you?
Yeah, I might as well.
Okay. Media type message will be sent out. Version 4 will be going out, and then we wait for further guidance from you guys.
I probably, when we do the working of last call, I might try to poke some of the directorates because they always show up late or never, just to try to get them in moving, but it wouldn't hold it up.
Yeah, well, yeah. Those directorates. Anyway, I shouldn't say that much. But in that case, I have nothing else to say. Thank you very, very much for your time.
Thank you.
Thank you.
All right. Laura, you're presenting VVC?
Yep. First of all, can you hear me all right?
Yes.
All right. Yeah, V3C, beta-based volumetric video coding format. So the next slide, please. So why I wanted to bring this up in the meeting was that I tried to submit the next version for the working group draft. Unfortunately, I couldn't make it happen before the meeting because the system deadline had passed. But what I anyways wanted to do was to run by you guys that there is a new version available. It's nothing but editorial changes, quite a few of them. The full diff is available behind the link here, and it's mostly just fixing typos and writing style. But below are a couple of copies of the diff file where there are most changes. And these basically just try to offer a bit more additional information for the reader. So again, nothing really technical or normative here. So if we go to the next slide then. So what we still are lacking, in my opinion, is a proper technical review of the document by other than the authors. I'm not saying that the authors are totally unable or incapable of doing the technical review, considering that the other co-author is also the editor of the V3C document in ISO. So there's sufficient amount of technical expertise, but we would really appreciate another set of eyes scrolling through the document and seeing what they can pick up. The reason why we want to kind of get this further feedback is that for now, we haven't made any technical changes for over a year. We've been doing minor editorial improvements here and there. And it would be very useful to start discussions on how to progress the draft, but without external technical feedback, it's rather difficult maybe to do so in this meeting. But anyways, we'd be interested in knowing if there are any tools or techniques available like best practices, how we can not force people to review the document, but really help get people engaged.
That is indeed always a problem in the IETF, especially for. So, I mean, yes, I think. Do we have anybody who would volunteer to review it? I mean, we as chairs could, but it'd be good to have more than just that. Anybody who's knowledgeable about payload formats and at least vaguely aware of volumetric video. Anybody doing related work anywhere? Well, I think we could. I mean, certainly try to get the chairs to do it, but yeah, I guess we should also probably put out some mail on the list to try to encourage some review. But yeah, I think I will try to take a look at that sometime in the next bit, probably after the meeting, but hopefully not too long after.
Yep, sure.
And then
I really appreciate it.
Yeah, and then after that, and then I mean, if we think there are no open issues, ultimately there's nothing stopping us from doing working group last call. But I agree that probably getting some technical review would be a good idea. So I will try to do that. And again, anybody else who wants to volunteer or is interested in this sort of thing, please also take a look. Right, are there any other? So that's your last slide. Yeah, that's your last slide. All right. All right.
There's just this last comment about 3GPP work items looking at volumetric media, and the problem with this is that it brings a bit of a timeline pressure as well.
Okay, that's
generally, okay. Yeah. So generally, they don't like to refer to IETF documents that have not reached the last call status, and ideally, this RTP payload format for V3C would need to reach that status by the end of the year so that the work on that front can continue. taking into account this real-time streaming
Okay.
capability as well. Otherwise, they will just have to deal with Dash and ISO BMF-based delivery. So
Well, thank you for that.
not
That's
optimal.
useful information. Yeah, and I don't see any reason why we couldn't achieve that. So we should try to. I agree. Let's try to get some technical review and move forward with that. And of course, if you have any 3GPP, if there's any experts in that area who would be willing to review it, you could reach out to. That would probably also be useful. You probably know that community better than we do. But I mean, obviously, we need people who are more RTP specialists to review it as well. Right, thank you.
Pull some strings.
Sorry, I missed what you said. Say again.
No, I just said that I'll see if I can pull some strings to get some people involved
Great.
in that front more.
Wonderful.
As well.
Wonderful. Thank you.
But thanks.
Thank you. All right. Okay. Next up is RTP over Quick.
So what was the next action on the last document?
We're going to try to get some more reviewers. We, as the chairs, will review it, and the authors will try to reach out to some other communities to review as well. We wanted to get more technical reviews before we go to working class call. And anybody else who wants to review is encouraged to as well, of course. All right, and you can go ahead.
Now? Yeah, cool. In the interim meeting last time, we updated our draft and said we would update some issues we have to clean them up and to make it easier to discuss different issues more clearly and more focused. I want to go through a couple of issues today, starting with congestion control. Next slide, please. We have, I think, 4 or 5 issues on congestion control. The first one is on avoiding nested congestion control loops from RTP congestion control and quick congestion control. We will later get to an issue which tries to clean up some of the terminology there. But here, first, one of our assumptions is that if you're using RTP, then mostly you are probably application limited. I think there may be some cases where this is not true, but in many cases it will be. And then also, if you're using RTP over quick, you probably want to rely on signals from quick instead of having additional signaling in RTCP, using bandwidth for things you already know from quick. And we are planning to add some guidance about using application level congestion control to solve this issue. We will reference issue 48, which I will talk about later today, which is about replacing RTCP or AVPF feedback with quick feedback. And then we will also add some guidance about using the appropriate quick congestion control. And then I said earlier, there may be cases for which application limited is not true. I think one of the cases may be where you have application data in the background, which is not RTP, but sending some data stream in the background. There should probably also be some guidance about that and what to do about congestion control in quick if you have other data being sent on the same connection. All right, next slide, please. Then there's issue 67, which is more like a meta issue about terminology and phrasing the discussion in terms of guidance instead of normative shoulds and musts. The actual guidance was discussed in the other issues, so this is more about how we phrase it in the draft. Next slide, please. Issue 68 is about removing mentions about disabling quick congestion control. I think that was one of the parts which was quite confusing in previous versions of the draft, or is still in the current version. Again, we will come to terminology about different terms regarding congestion control, and then I think the next slide, but we want to remove this explicit disable quick congestion control, because it seems like it's, or it sounds wrong. And we want to note that a quick sender or stack can do this if it's acting on its own. But of course, we say don't do this. And if you do it, do something else instead. Of course, someone's sending data still has to do congestion control. The idea there was just, if you're doing RTP congestion control on top and you're not sending anything else, then from the network perspective, it looks the same if you have congestion control in your quick stack or in the application implemented. So yeah, this phrasing of disabling quick congestion control might be quite confusing, and we should change that so that it still says we have to do some congestion control, but it may be implemented differently from the quick stack. Next slide, please. And then we have issue 69 about explaining why we're not making BCP recommendations for different algorithms. I think we already have references to 2 algorithms from RMCut in the draft, but we just say these are examples of some algorithms. And the idea is to not fix on specific algorithms, because there may, of course, be new congestion control algorithms appearing in the future. And the algorithms in RMCut are all still experimental. And we would rather like to provide guidance about what kind of algorithm to look for, rather than to naming specific ones in our draft. Next slide. Yeah, then the one about terminology that I mentioned earlier, we realized that it's quite confusing to talk about quick congestion control and RTP congestion control and saying things like disable quick congestion control or using specific RTP congestion control without really defining these things. So we have this issue about fixing that, and we already opened the pull request 73, which introduces, I think, 4 definitions for what we mean by saying quick congestion control, which says basically when we talk about quick congestion control, we mean the software component in Quick that implements some congestion control algorithm, and the same for RTP. And then we talk more specifically about the different kinds of algorithms that could be something loss-based or something that is more focused on low latency. And again, we're trying to define what properties we are looking for instead of naming specific algorithms here. Okay, next slide, please. Then that was all for congestion control for now. Then we have an issue 45, which was already discussed briefly in London, I think. We realized one more issue with that, which is why I bring this up again. So the issue with stop sending is that, or the idea of using stop sending is that the receiver can ask a sender to reset a stream. And use cases for this are, for example, to let the receiver tell the sender to stop sending a specific frame because the deadline of that frame has already passed. Or a different use case that could be thought of is that a receiver wants to unsubscribe from a certain SVC layer for some amount of time until there's more bandwidth available. But using this stop sending frame requires the knowledge on the receiver side about what data will be following on this stream, because otherwise the receiver cannot really say, I want to cancel this stream, because it may happen that there's another frame following on the same stream, and the receiver would accidentally cancel also the following stream. And to do the same for SVC layers, the receiver, of course, also needs to know how the SVC layers are put into different streams so that it can actually cancel any of them. Yeah, Jonathan.
Yeah, I mean, I'm not sure, thinking of that, I don't quite follow how the, unsubscribing from SVC layers would work, because you'd have to send a stop sending for every frame of that layer, right? That doesn't seem, and you'd have to know that the stream exists first, so that doesn't seem, and know that those streams are SVC layers. It doesn't seem particularly practical.
Yeah, let me finish the next slide. I think maybe then the question will already clear.
Okay.
Stop sending is for the stream, not for a frame, right?
Yeah, right. Stop sending is to, or is used by the receiver to tell the sender, please reset the stream. And the sender would then know, okay, if the sender puts one frame on every stream and not more, then the sender would know, okay, I should cancel this stream, so the receiver is probably not interested anymore in receiving this frame, and then I can stop resending anything that's missing on that stream. And that works if there's only one frame per stream, but let's see on the next slide the issue we have with this, because in London in the discussion, I think we had a tendency to restrict senders to always put exactly one frame into streams so that we can allow this use case. But we think that that may lead to problems, for example, for codecs which produce very small frames, because then we would have to open a lot of streams very quickly. And then, of course, also if we don't require senders to have this boundary of one frame after every, or closing the stream after every frame, then the receiver needs to have some knowledge about what is the way how a sender puts frames into streams. And so our current plan is to leave this explicit feature out of the draft while still making it possible to have some signaling defined for such use cases externally, because we don't have signaling at all in our draft. That needs to be done anyway. If there are these use cases, then that could still be implemented, but we would like not to define any complex signaling for this in the first version of this draft. Yeah, Bernard?
Yeah, just to answer Jonathan's question, basically the second case is where somehow, as was mentioned, the receiver knows that there's a stream per layer. So you'd obviously have to cancel all the streams on which the stream you canceled depended, right? So if you canceled the first extension layer, it wouldn't you'd have to cancel the upper ones too, because they depend on that and they wouldn't be decodable. So anyway, that's the kind of a logic. Does that make sense, Jonathan?
Jonathan? We can't hear you in the room if you're speaking.
You need to unmute, Jonathan.
Yeah, it helps if I unmute. Yeah, sorry about that. Yeah, so I think that I'm agreeing with the second bullet point here. I think the sender is in a much better position to know when to cancel a stream or remove a layer than the receiver is, because the receiver would have to cancel each stream as it discovers, gets the first packet of that stream and discovers, oh, hey, this is a layer I don't want, each time, which sounds like it would be very inefficient. And I think I agree the sender is in a much better position here.
Okay. Alan.
Alan from Dell. My question is, are you then saying that you're going to, your spec will say the receiver must not ever send a stop sending? Or because the quick layer defines this message, which the receiver can send if it wants to, and the sender needs to reset if it receives it.
So the idea is we had this as a feature in a previous version of the draft, I think, when we still had this requirement of sending exactly one frame per stream and then closing the stream. And now we're just thinking to drop this feature, but we're not going to say the receiver must never do this, because it's part of Quick, and we would like to allow this for external signaling. If someone wants to define that outside of our draft, then that should be fine. We would just drop this from as it was before in our draft.
Okay, thanks.
Peter.
Test, test, test. Is that how you're working?
Yes, we hear you.
Okay. So I have a couple comments. One of them is that I don't think there's going to be a real issue with opening many streams very fast, at least in my experience with quick implementations. However, if you have very small streams, then stop sending doesn't really mean anything, since one packet will end up being the entire stream. But I do agree with the comment that was just made about it would probably be a good idea to at least define what the sender should do when the receiver sends a stop sending rather than leaving it undefined. And I think one approach might be to say that if the sender receives a stop sending, it does not continue transmitting the current frame, but then it can open a new stream and send any future frames on a new stream. And I think that would
Yeah,
yeah,
that makes sense. I think we can add a note for that. That sounds good. And for the first comment, I think
the one,
that is
sorry, the one question. Sorry, I might be jumping the queue. I'm sorry. Yeah, I am. Go ahead, Lucas.
So for the first comment from Peter, I think it's true that if you have a lot of small streams, then stop sending doesn't make much sense because they will be closed very fast. But if we require sending only one frame and then opening new ones, then that could also happen or be used for, it could be used as a feature, but it would also impose this requirement on very small streams where we wouldn't use stop sending, but we would still have the requirement then on even these small frame streams.
Right. I understand that the desire to allow the sender flexibility to send more than one frame in a stream. That's why I'm suggesting that if it receives a stop sending, it would just drop the current frame and then can continue sending frames on a new stream.
Yeah, I agree. Okay. Lucas.
Hey, Lucas Pardy at Cloudflare. Just to echo like what Alan and Peter said, I think dropping it as a feature that you promote to use is probably a good idea, but that you need to capture the considerations for when it does happen. These are like a feature protocol, a feature of the quick transport protocol presented to applications that could be used, and even if you don't want to use them, they could happen. So just give some considerations, because if you leave it undefined, people will potentially do different things, and they may not even know what to do and have to come back and ask questions. So whatever we think now, just try and capture them. Happy to give some review there, just in terms of generally how these things can be captured at an applicability layer for Quick. So I'll take a task to review this stuff. Cheers.
Okay, thanks. So yeah, I think we can definitely add a note about what that is. Of course, it's a part of Quick and receivers can use it. We were not going to say it must not do it. And we can add a note about what happens if a sender receives this frame or what it should do. Just don't want to have this as an explicit feature of, hey, you can cancel frames by stop sending because the sender might send more on that on the same frame, same stream.
Yeah, so I was actually going to raise an issue, which I think Alan also just raised in the chat. The problem with saying the feeder suggestion about saying stop sending means don't send the current frame, but send future frames is the sender might not know what the receiver thinks is the current frame, because stop sending, at least according to Alan, and I was worried about that, doesn't include an offset. So you don't know if you don't know which, the sender doesn't know which one the receiver thinks is the current frame. So they might disagree on that. I'm not sure that works in practice, but somebody with more quick knowledge than me might need to be able to speak to that.
Yeah, I'm not sure if I got that.
Just to repeat what Alan said in the chat. Let's see. Did you just say that if there's more than one frame in a stream, receiving a stop sending means the sender could resend some frames in another stream, but stop sending doesn't include an offset? How will the sender know which ones the receiver didn't want? Because the current the sender's notion of what is the current object might not match up with the receiver's notion of what's the current object, because there might be, because obviously there's, the receivers, there's going to be stuff in flight at the time the receiver.
Yeah, so this is an argument for keeping it as a feature because then the receiver could tell the sender what's the current
I don't.
object?
I haven't gotten so far as saying it's an argument. I think it's an argument saying that there's a problem with Peter's proposal that I'm not sure it will work in practice. So we might need to think about that some more as to what it actually stop sending actually means.
Okay, so yeah, I'm still not sure if I got this, but if there's a problem with that, maybe create an issue. I think I need to think about that then. So maybe I'm misunderstanding that now.
Okay. Bernard, you're next in the queue.
Yeah, I would wanted to echo what Jonathan said and suggest even further problems, which is that if you've sent a stop sending, that basically says, I don't want you to send on this stream. And I don't think it's helpful to interpret that as a request for another stream, right? Because you basically said that you haven't asked for another stream, right? You're just somehow you said I don't want you to send this stream. It's like if at a restaurant somebody said, "Would you like dessert?" and you say no, and then they interpret that, "Oh, I'll bring out another dessert." Right? It's not what you asked. So I don't think it shouldn't be. It should be considered as stop sending. It's a specific quick construct. It is not a request for something else.
Yes, I think if we keep a note about how the sender reacts to this without mentioning it as a specific feature to cancel frames, it can still happen because the receiver can still use it as a quick feature. And then we add a note about how the sender should react to that. And then we could, of course, add to that note that what you just said, if a receiver sends it, that's not a request to send it again on another stream. Does it make sense?
Yeah, I mean, we have RTP messages to request retransmission like NAC or stuff like that, right? So there's a way if you wanted to ask for that, there's a way to do it, but that's not it.
Yeah. Okay, Peter?
Both Jonathan and Bernard, I think Jonathan is right that there is a problem with kind of a race condition where one frame is in flight, then the receiver says, oh, I don't want this anymore, it's been too long, so it sends the stop sending, but then that frame arrives and the sender starts sending the new one, and then it gets the stop sending. I went and checked the quick draft, and stop sending does not have an offset, so I think he's right, this is an issue. I think it would make sense for the draft to say that a receiver should not send stop sending, but I think that it would be a mistake, responding to Bernard's comment, I think it would be a mistake for the sender to interpret stop sending as, okay, I can't send any of the frames that I was intending to send on this stream. So if there were a sender that decided, okay, I'm going to send all of my audio over a single stream, and then it got to stop sending, it just decides, okay, now I can't send audio anymore. I think that would be kind of silly. So I think this is a kind of thing where we should probably say, the receiver shouldn't send this, but if it does, then the sender should interpret it as, okay, I can't use this stream anymore, but if I want to send more media, I still can.
Yeah, that. If there's a race condition, like you mentioned before, maybe we should have another issue discussing that if we, that should be addressed, I think. But we don't have any requirement on the sender to put, for example, all the audio in one stream. So yeah, maybe there's more we need to say about, more detail to what I thought before, what we need to say about how a sender needs to react to receiving a stop sending frame, because it can then open a new stream, of course, sending however much of audio. And there needs to be some consideration about how to handle this without acting as serving more DSIR without being requested to. Lucas.
Hey, Lucas Pardew, Cloudflare. HB3 kind of has a similar interaction here. It's different, but it has a similar need to react to what the quick transport does. But there's the cancel push frame, which is used for server push, which is the notion that you're going to push an object, and at some point that object will arrive on another stream. So you could like cancel that stream itself, or use the cancel push frame to cancel the interest in that object explicitly before it arrives. And there's these kind of raciness conditions that apply there. And the spec goes into some detail around that. So it might just be worth having a look there to see if there's anything you can take. It won't map directly to what we're trying to do here, but it might give some inspiration to the kinds of things, kind of treatment we should give this.
Yeah, that sounds helpful. Thanks. Okay, then next slide, please. So max streams. There are scenarios in which the max streams limit could be exceeded when we have a lot of RTP streams and a lot of quick streams are opened concurrently. Our draft currently says the number of packets that have to be transmitted concurrently depends on several factors. Then we name a couple of factors. And then it says receivers are responsible for providing senders with enough credit to open new streams for new packets at any time. We could be more specific about how to calculate how to increase max streams, but it's kind of hard to come up with a very precise calculation for that, because there's always the case where we have background data flows that may also use some of the credit and may need to be rate limited to avoid using all of this credit. I think a similar issue has been brought up in the mock working group by Christian Heutemer. And I think this only applies to unidirectional streams, because we are only using unidirectional streams for RTP, and the max streams says if you have a max streams of 1, then you can send or open 4 streams, which is client and server initiated uni and bidirectional. And since we are only using one of them, other streams could of course use the other types of streams. Yeah, but I'm not sure if we need more or to add more guidance or considerations and how that exactly should look like. So it would be helpful to have some input from the working group here. And I see Bernard in the queue.
Yeah, so in Web Transport, we did discuss this, and it turned out that there were some scenarios where you would hit the limit. For example, in some implementations, the default is like, I think, no more than 100 simultaneous streams. So if you were doing a conference or something and you had a lot of participants, you could hit the max streams limit. So the answer is, I think we're looking into how the client can, how you can make a specific request that, hey, I'm trying to do a conference with, you know, up to 1,000 people, allow more max streams. Anyway, this could be potentially an issue if you're trying to do something that would have a lot of streams and you don't make it clear ahead of time.
Yeah, I think that that could definitely become an issue, especially if you have large conferences where you serve many streams concurrently. I'm just not sure how to solve this in the document, because there maybe, I mean, if we wanted to tell the receiver ahead of time to open or to give max streams or give enough credit for a lot of streams, then that may need some signaling.
This is probably something that would be handled in signaling.
Okay.
Yeah, so you may not need to deal with it here, but it would be handled in the signaling document.
Yeah, but then we may still want to add a note here to consider that when implementing signaling. Spencer.
Yeah, Spencer Dawkins. So what I think I just heard was that it's difficult to describe a specific calculation in a general, for general use, or what you should be doing, but that adding guidance, which could be just remembering to do this and perhaps giving an example of what it would take to get you past 100 streams, which is the default. So is that about right?
Are you asking about the default or about adding the example? Is right.
Giving, let's do it in two pieces. Giving the guidance. Is that about right?
Yeah, I think that sounds good.
Okay, and possibly giving an example of how you can get past 100.
Yeah, we can certainly add that.
Okay, cool. Thank you.
Okay, then I see the queue is empty. So next slide, please. Disabled datagrams, I think that was raised by Lucas some time ago. And I see that we discussed this in the issue. I think I mostly misunderstand the issue in the first place, but that kind of helped clearing that out. So Spencer wrote a summary about this, which says that if both sites don't support datagrams or provide zero credits for streams, then you won't be using streams or datagrams, depending on what you have. And we will add details for considerations for this. Like if you don't have datagrams, then you can probably not use datagrams. And if you want to send streams, as said before in the previous issue, you need to have max streams set to a limit that allows you to send enough streams to get your RTP packets through. But then related to that is what issue mentioned, what Lucas mentioned in the issue is if we have signaling externally, which says we want to do RTP over quick datagrams, and then we open a quick connection that doesn't support datagrams, then we should maybe mention something about this in the draft that this shouldn't happen. And yeah, we will work through what to add there. And I see Spencer maybe want to add something to that point.
Yeah, thank you. So I would invite Lucas to tell me whether I'm hearing, I understood him correctly, but this is basically, I have a quick implementation that's just accepted a, that's just accepting a incoming connection. What would it be good, not required, but good for that implementation to know early in the life of the connection? And so the thing, we've talked about this in the very specific case about congestion controller mechanisms, but Lucas up-leveled this, at least in my mind, beyond that to say, here, datagram, knowing, are we doing datagram streams or both early in the life of the connection, being a good thing to do, if I understood the discussion correctly. But so anyway, so like I say, it's just me observing that this is an up level of a discussion we've had probably at too specific a level in the past.
Sorry, I didn't go in the queue. Lucas here. I don't remember this issue much, so I was just trying to quietly refresh my memory while Spencer was speaking, but I didn't quite get there. I think that, you know, with these things, they're in the transport parameters, so they're sent by the client as its first message, and they're sent by the server as its first message if it accepts that connection. So, like, you're going to know from the very point you have a quick connection what the capabilities of it are. So at least the initial ones. With like streams as a last example, you'll have an initial stream credit allowance, and you can then like immediately bump that up with max streams. So some servers could, they shouldn't in practice do this, but they could send an initial credit limit of 0, and then immediately they'd send 1 million afterwards, which would be weird but legal and quick. That's probably okay, but with the datagram one, it's like if you're a client that wants to use datagrams and the server says, sure, but I'm not going to use them, what's the failure condition? Do you immediately close the connection with a special error code to tell the server, like, I'm a certain class of client that needed to behave this way with you, and I didn't? I don't expect these to be like super dynamic. Like the server should be advertising its capabilities in a unilateral way, not trying to anticipate what the client's doing based on its transport parameters. That's a model we kind of went with Quick and suggest is still used, but it's not strictly enforceable. So yeah, I need to refresh my memory on this issue and maybe try and help a bit so we can just close it. Does that sound okay? Or...
what was the last sentence about close it?
Like, how come, what do you need from the working group or me to help you resolve this issue? That would be a better way to phrase my question.
Okay, yeah, I think there are 2 things we want to do at least. One is to say that if you do signaling outside of the quick connection that says we're using RTP over quick datagrams, then the opening of the quick connection should support datagrams. And then we want to add something, like you said, like if what happens if it's not the case, like if the quick connection does not support it, then how to handle that, do an error code or something like that. And maybe some guidance in that regard, how to handle this condition would be helpful, I think. Yeah.
Yeah, that sounds good. Like I can work with you to prepare some text that at least works for me, and then we can put it to the working group for.
That would be cool. Yeah. Thanks.
Yeah, I'm thinking that this would be something that you'd signal, right? Like you might not care about datagrams, but the main thing is you signal what you want to do, and then you would expect that to be mirrored in what happens in the quick negotiation. Does that make sense? Like if you don't care about
yes.
datagrams, well, fine, you're not gonna. If both sides unsupported, you don't really care. There wouldn't be a need for an error. Whereas if you require it, then there would be.
Yes, true. I think if we require that in the signaling that we use datagrams, then that's of course what we expect from the peers when they open the quick connection, but still may be helpful to have to say something about what a peer should do if the other peer doesn't do what was signaled. Does that make sense? So to have some error code or something defined what to do.
Yeah,
when...
yeah. If it doesn't do what's signaled, it could be an error if you're requiring something that the other side can't do. That's an error that would occur not at the quick layer but in the signaling, right? And then there's if you signaled and agreed then and didn't get what you want, that's kind of a different error.
Yeah, exactly. But what would, like, if we signal something and then in the quick connection it doesn't mirror what was signaled before, then we probably want to have or close the connection and give some error code or something instead of just do nothing about it.
Right. Yeah, I mean, you signaled and expected something, you didn't get it, that would be an error condition.
Yeah. Okay. Yeah, then next slide, please. Supported topologies. We already had a small section about supported topologies before, which was very high level, and now we added a longer table of RFC 7667 topologies in a pull request 72, which lists the section number, shortcut names of different topologies, and then says for each of these topologies is this supported by RTP over QUIC, and if it is possibly supported, then what needs to, or what requirements need to be fulfilled to make it supportable by RTP over QUIC, and if no, then what are the blocking factors, for example, that multicast is not available in QUIC. Yeah, I think there's a lot of things that could be said about this that could either update RFC 7667 or be its own draft if we explain everything in very detail. But having this table already should help in determining for RTP over QUIC how it works with different topologies. And yeah, we would like, it would be helpful to have a few more eyes looking on PR72, I think. So if we got all the topologies right, if that makes sense, what we say there. And yeah, I don't know if, or what to do about updating another RFC or writing another draft about this. But for now,
I don't think it needs to be in. I mean, sorry, the queue. First, I was going to say you can ping me on that PR, and I'll try to review that.
Okay, that sounds cool.
So just at me on GitHub, and I at this point wouldn't say that getting into huge discussions of topologies here is useful unless you think it would be useful. But I don't want to generate a whole lot of text for things that would not be terribly useful to people.
Yeah, maybe. Yeah, maybe we can have the discussion about updating that one later.
Yeah.
Or having another draft. For now, having a review on PR72 would be great.
Okay. Yeah, like I said, just at me on the PR, and I'll try to take a look at that.
Okay, will do. And then I think the next slide, which is I think the last one, on feedback. I think I briefly mentioned that on the very first slide. We had a list of a couple of RTCP packet types in the draft before, and we listed for these packet types which of these fields can be replaced by feedback that is already available in QUIC. We have now added a longer table similar to the topologies table, which lists for a lot of RTCP packet types. I hope I got all of them, and feedback types with the document number where is this feedback and packet defined, and can QUIC provide similar or same feedback, and what is required to provide the same feedback. For example, if we need a timestamp extension or something like that in QUIC to implement that same feedback. That is in PR71. Magnus.
So is this not applied, or is it, so there's a PR for the improvements to that?
Yes.
So I'm not having looked at the PR, but is there, reading the text, I think it's so far fails to consider what the aspect of saying, when do the system need full end-to-end RTCP functionality versus when do you only need the transport, for example, heuristics of the next hop? So, I mean, RTP middle boxes that has enough and capabilities to adjust bit rates, etc., might work fine. But if you have a system like a simulcast system that also looking at the whole system, how well the bit rates are, and trying to adjust the simulcast bit rates that it's providing, that maybe have a different requirement on RTCP. So I think there's some considerations here about when do you need them and at what rate for the system when you configure that for RTP and RTCP. So rather than just replacing them, I understand that in most cases, yes, use this directly for your immediate on the end, that's fine. But the considerations for when you need the RTCP messages end to end across the whole multi-party sessions probably needs to be there.
Okay, yeah, that makes sense. I think we should add a note, or maybe I can have a to-do in the notes or something for me to add considerations about that. Great, thanks. And then Jonathan. We can't hear you.
I'm sorry, I keep forgetting to unmute. Yeah, I think the other question is whether it be, whether these features are actually, quick features are actually exposed to typical quick APIs, whether you actually have access to that information. I mean, the most restrictive, of course, being web transport, but also other APIs, so it might be worth some discussion of that, though obviously that's implementation specific.
Yeah, I think the PR71 is also not, or it is not as detailed about the new fields we added now as it was about the previous fields we had before. So yeah, we may need to add some more detail about different fields there. Yeah.
We're running a bit behind, so I think we need to go to the next presentation.
Okay, yeah, this was also my last slide. So if there's no one else in the queue, then we're done. Thanks.
Thank you.
Who will be presenting this one?
Thank you, Mr. Chair.
Srinivas, yes. All right. Go ahead, Srinivas.
Thank you, Mr. Chair. Can you hear me?
Yes, I hear you well. Go ahead.
Yeah, okay, thank you. Yeah, so today basically I'll be presenting our draft on RTCP messages for decoder energy reduction. So in this presentation, I'll provide a brief background on the decoder energy reduction methods discussed in the MPEG specification, followed by the problem statement and our proposal. Next slide, please. So recently, MPEG has developed the ISO IEC 23001 Part 11 version 3 specification, which is mainly on the energy efficient media consumption. And this is also known as green metadata. So this specification majorly specifies the metadata that facilitates the reduction of the energy usage during the media consumption time. So the green metadata specification mainly proposes two types of decoder side energy reduction methods. And the first type consists of the metadata generated at the video encoder side, which basically provides information about the decoding complexity of the generated bit stream and the quality of the coded content. And this type of metadata generally is conveyed over the supplemental enhancement information, SCM, also known as SCM messages, which are basically provided in the video coding and carriage standards. And the second type of message basically consists of interactive metadata generated by the decoder, which is basically conveyed as a feedback to the encoder, and the encoder adapts the decoder energy consumption. So in the first type that we discussed, basically the complexity metrics indicating the picture decoding complexity of a bit stream are generated at the encoder, and they will be transmitted to the decoder. So these SEM messages are used in the bit stream that was defined in the video codecs or in the video's carriage standards, system carriage standards. So these complexity metrics basically include the complexity of coding, various coding tools such as interprediction, filtering, non-zero transform coefficients, deblocking, etc. So basically the first type of message carries these complexity metrics and will be informed to the decoder. And in the second type, basically in the interactive signaling, a receiving device sends the metadata, which basically instructs the sending device to modify the complexity of the decoding operations for the bit stream and reducing the receiving device decoder power consumption. So, and the second type includes basically the spatial and temporal resolution request, or a decoder power reduction request, or a coding tool based request. So the green metadata draft shown in the slide, basically the RTCP green metadata provides the support for spatial and temporal resolution request to reduce the decoding power, and the other basically informing about the decoding power requirements, reduction in the decoding power requirements, and the coding tools usage was basically defined in this draft. Can we go to next slide? So the main issue here is like how to reduce the energy usage in the decoder during the media consumption time. So the main things that we addressed here was like how to signal the percentage of decoder operations reduction required by the decoder, so that how can the decoder inform the sender about this requirement, and how to signal the desired coding tools configuration to reduce the decoding side power consumption. And when basically when a sender receives these kind of messages, how the sender inform the changes in the decoding operations or the coding tools that were used for the request. So how basically the sender will inform the receiver, or the sender in the sense like we can say encoder informs the decoder about the changes that are occurred in the sending side and the encoder side. And finally, the required signaling between the sending and receiving devices for all these capabilities. Can we go to the next slide? So basically the current proposal discussing about the interactive signaling of the metadata generated by the decoder. So as specified in the green metadata specification, and this includes basically requesting for a change in the decoding operations, or enabling or disabling certain coding tools configuration at the encoder side. So for this, basically, we extended the RTCP feedback messages that were defined in the RSC 4585 and 5104 with two new RTCP feedback messages. So we defined the decoding operations reduction request and the decoding operation reduction notification. So basically the DORR message is like from the decoder to the encoder requesting for a certain amount of percentage reduction or increase in the complexity of the decoder side, and the DORN is basically a notification from the sending device to the receiving device. And these also, these messages can also be used with the RTCP feedback messages defined in the RTCP green metadata, which is basically the temporal spatial resolution request and a notification. Can we go to the next slide? So here, basically, we are providing the feedback control information syntax for the DORR and DORN messages. So if you see basically when the type field that defines whether the decoder is requesting for a decoder operations reduction, or basically type of coding tools that it requires to be disabled or enabled at the encoder side. So when t equal to 0, it will be like operations reduction requirement. And when on the type is 1, it basically requires that certain coding tools are required to be switched, enabled or disabled. So here we are basically, it's a 6-bit field, and we are presenting the operations that was defined in the green metadata specification. The syntax and semantics of the operation when t equal to 0 is same as what is defined in the green metadata specification. And when t equal to 1, basically we are defining that coding tools that needs to be disabled or enabled by the codec, by the decoder, by the encoder. So the decoder basically requests those things. And a DORN is basically a notification message. So it basically informs about like if the operations are requested, the decoder operations reduced, or basically the tools that are enabled or disabled. It will basically inform the receiver about the changes at the encoder side. Can we go to the next slide? And basically, the communication between the receiver and the sender is basically done using the session description protocol. So the support for the DORR and DORN messages will be provided in the STP as an attribute to the codec control message parameter. So as shown in that slide, and we provided an STP offer and an answer for the same using this. Can we go to the next slide, please? So basically on the next steps, so we submitted our draft and we would like to actually gather the feedback from the IETF, the AVT core working group. And we basically, we are asking for the discussions in the AVT core reflector. And based on the discussions and the comments we received, we can basically update and review this the draft. Yeah, thank you.
Raul, you were first, thank you.
Hi, hello, this John. Just how much power reduction have you achieved by modifying encode-decode cycle in this way?
So it's basically requesting a percentage of the decoding or the coding tools based thing. So let's say, for example, if it has to reduce like a 50% decoder side reduction, then it will basically inform the sender using the field with t equal to 0, and the percentage is basically calculated as it's a 6-bit field, so which basically takes values from -31 to +32. So you can basically, which represents actually a 65 to 70% of the reduction you can request up to maximum.
Have you achieved that?
Yeah, well, basically, yeah, it can if we disable certain coding tools and all, that we can achieve a bit. Yeah, but I'm not sure. I mean, like, we didn't work on exactly on the implementation side aspects. But probably I can check with our back office team, and then I can get back to you on that.
Thank you.
All right. So yeah, I think I would say that, technically this does seem like the correct, technically correct. My question for adoption is how much interest is there from implementers and whatnot to actually implement this? And obviously, you have a number of authors, which is encouraging. Different, but are they're there from? So do you know what the community interest is in implementing this?
So I mean, we have support from the FAU University, which is also working on this topic, and we're basically gathering support from few other people who are interested in this topic.
Okay. Magnus?
Yes, Magnus. But my question here was, how does the requested energy reduction versus bit rate versus quality look for? I mean, do you have some materials about that?
Yeah, so basically, we were not really talking about the bitrate because we already have different quality requirements. So, for example, if you wanted to request for a particular bitrate, we do have like a TMMBR request and notification messages, but this is not about like changing just the bitrate information, but it is basically a little beyond that.
Yeah, I understand that, because to my general, in general terms here, my understanding is that if you reduce the complexity of the encoder, your bitrate goes up for the same quality, and likely you're reducing the energy consumption of the encoder, but then you may require more energy in the transport system instead to transport those bits. So I just wonder about how that relationship, if you looked into that, or if you're just saying, okay, we're going to reduce the quality when we reduce the energy needs.
So that's why we were basically mentioning this as not overall decrease of the things, but it is the decoder side energy reduction, which basically concentrate. Yes, I understand it. It definitely increases a bit of bit rate when we try to basically disable some of the coding tools, which basically takes about a bit of power consumption, definitely. But this is majorly concentrating on reducing.
I think we're going to need to cut this discussion short to move on to the next item.
Yeah.
Sure.
Thank you.
Thank you. Yeah, but we are open to the questions in the reflector.
Okay, Peter Thatcher is next.
All right. Can you hear me?
Yes.
After we spoke about S-frame last time, Jonathan Lennox and Ewan and I discussed how we could solve this. And we were hoping to get a draft, but we missed the deadline. And so I put together some slides to try and at least continue making progress here. So this is my best attempt at summarizing what we were going to write down in a draft. Next slide. So a little bit of a reminder, this is the architecture for S-frame, which basically injects an encryption step between encode and packetize. We're talking about the per frame version of S-frame here, not the per packet version of S-frame. And we're talking specifically about how we do the packetize step that happens after the S-frame encryption step. Next slide. And if you look at the S-frame spec, you'll see that on the right is defined what an encoded frame looks like after it's encrypted by S-frame, and then the S-frame metadata is serialized with it. So that's kind of a wrapped or encrypted S-framed version of an encoded frame. And the goal is to stick that into an RTP packet. And obviously, if it's very small, like an audio packet, that's very easy. But if it's bigger, then you have to packetize it into many smaller packets. Next slide. So the question is, how do we do that? So if you have this slightly simplified diagram of how this works, you have an encoded frame, you S-frame it. In other words, you do the step that creates that picture that was on the right on the previous slide. And then we need to split it up into many RTP packets and then be able to undo that process. So it's pretty straightforward desire. That's what all packetization is. But how? Okay, next slide. So this is the solution that we came up with, I think. You can correct me if I'm wrong, Jonathan, or you if you're in the call. So basically, we decided to packetize twice. Once is to run the codec-specific packetization with an infinite MTU, basically. I call that big RTP here. And then pass that into S-frame to be encrypted. And then take that and break it up into small chunks. And then to take the headers that came out of the first packetization and use those in the second packetization. And I'll get into details of what exactly that means. But basically think of big RTP goes into S-frame, gets split up into small RTP packets of the S-frame payload. Next slide. So the questions which we have answers for are what goes in that RTP header of the smaller RTP packet.
Bernard, are you in the queue?
I had a question about an earlier figure, I guess 2 slides back. Yeah, this one. Basically, one more. Is the difference between S-packet and S-frame the order of the RTP split up and the S-framed encoded video frame? So in other words, we took this picture and put the RTP kind of packetizer before the S-frame encoded, that would be S-packet?
Yeah, well, if you go back one, I think maybe two. Yeah, two. Another one. So, right, we're not doing the thing where we packetize into small RTP packets and then encrypt. We're doing the thing where we encrypt the entire frame and then packetize. That's what we're talking about here.
Okay, thank you.
Okay. So back to how, okay, in the small RTP packets, what goes in the header, what goes in the payload, what is the process of the packetization, what is the process of the depacketization? Next slide. So what goes in the header? The payload type for the header is an S-frame payload type with one of these for each clock rate you need. So for example, in this SDP, there might be an audio S-frame payload type with 48 kilohertz and a video S-frame payload type with 90 kilohertz. And that is so that on the wire, you know it's S-frame. The other headers, such as our SSRC timestamp, marker bit, header extensions, those all just come from the big RTP or from the codec specific packetization. And then the sequence number is just incremented like normal. Next slide. So you might be wondering, where does that payload type from the codec specific packetization go? And it goes in the RTP payload. So this is not the same as how RTX does it, where it sticks it in the inferred payload type from negotiating lots of payload types. This is sticking the kind of real or inner payload type in the RTP payload. And beyond that, it's really just a fragment or a chunk or one of these pieces of the S-framed result of passing the big RTP payload into the S-frame encryption process. And then we can also potentially have an optional bit of metadata for making forwarding easier for an SFU, but I'm short on time, so I'll just move on to the next slide. So how does this packetization work? We've already talked about it, but being pretty explicit here. First, you packetize with the codecs packetizer into one big RTP packet. Then you run S-frame on that big RTP payload. Then you fragment the S-framed big RTP payload into all these little fragments. For each fragment, you create an RTP packet, which has the fragment as the payload. And you copy the SSRC timestamp header extensions and marker bit from the big RTP packet over to the little RTP packet. And you move, you use the payload type for S-frame in the little RTP packet. And if I forgot to say prepend the RTP payload type for the big RTP, maybe I did, but make sure you do that too. All right, so then for depacketization, you have to collect all these RTP packets for a given S-frame, concatenate all these fragments together, remove the prefixed big RTP payload type, decrypt the S-frame into the big RTP payload, add back the RTP header, which you can get from the first RTP packet of the S-frame, and replace the payload type with the one that was in the payload of the S-frame. And then you can pass this newly created big RTP packet into the codec-specific depacketizer, which just has to depacketize one packet. So next slide. There are a couple things that we haven't quite figured out. Things like, do we need a frame ID in there to be able to know which packets go with an S-frame? Do the header extensions need to go on all of the RTP packets or just the first one? Maybe it's different for different header extensions. Does this payload, this inner payload type go on all the RTP packets or just the first one? And if we have optional data, how do we indicate the presence of that? And does the sequence number matter when you pass the big RTP into the big final codec specific depacketizer? But the real big question, next slide, is if we do write this up in a draft, can it be adopted by this working group? And that's it for my presentation.
Magnus?
Yeah, Magnus. First, a question for clarification. So the big RTP packet is just the payload. There was a bit, it mentioned both packet and payload that around the big RTP. I understand you create
well-
a virtual header, but you only S-frame the RTP payload of the big
Correct.
packet. Yeah. Okay.
Correct.
Good. I think I find this a reasonable way forward. And I think you have a few questions, but they should be relatively straightforward to answer those on the previous slide. But yeah, I think this is in the right direction.
Good. Thank you.
Yes, I think your next step should be this. Carol, go ahead.
I must admit that I haven't read the draft yet.
Well, yeah, there isn't
But,
one written yet, so that's you have a good
yeah,
excuse.
that's a good excuse. But I do see that there are certain definitionals that I don't quite understand how you work around. In particular, I'm not sure where which pieces of the header of the big RTP payload are real and which ones are just there for expositional purposes in the draft. But I'll make more sensible comments on that when I actually have a draft in my hands.
The two that are kind of unreal, if that's the right word, are the payload type and the sequence number. Since the payload type gets replaced by the S-frame one, and the sequence number is used for the small RTP packets, not the big one. So other than those
And
two.
the SSRCs?
Should be the same.
CSRCs?
Same. I think.
Bernard?
So I had a question about the SDP negotiation. So it kind of looks like skip, right? In that it's basically giving you just saying audio S-frame and video S-frame. Except in skip, there's this protocol inside of skip that does the negotiation. So how would the negotiation of the codecs actually work in this scheme? Because there's no S-frame isn't like skip, right? It doesn't have kind of a
Right.
command format that goes back and forth.
Yeah, you would still need to negotiate all the all the payload types that you would want to have the S-frame inside reference in the payload.
Yeah,
type
but how does
inside.
But how does that work? In skip it works because skip itself does that, but S-frame doesn't, right? So how does that ever happen?
Well, if you're using SDP, you would just negotiate all the payload types like you currently do, but just add an S-frame payload type, or maybe more than one if you need different clock rates.
So there's like two offer answers. One, is that like encrypted or something between the endpoints, or?
No. You're just adding an extra payload type, which is S-frame, that allows you to take the other payload types and encrypt them.
Spencer?
Oh, yeah, thank you. So I have a much smaller question. We had a significant amount of conversation, I believe, in London about S-frames and quick for the RTP over quick draft. I think that where this is ending up is that is not a RTP over quick specific topic. So that this draft would be a good place for anything about S-frame to go forward. and that we should probably close the issue in RTP over quick. Does that sound right?
Yeah, so I started this discussion in RTP over quick because of the difficulty with forwarding from small RTP packets to large ones over a stream in quick when S-frame is involved. And so, yeah, this is trying to solve that. So you wouldn't need to solve that in RTP over quick if it's solved with this.
You have no idea how pleased I am to hear you say that. Thank you.
I think I was going to respond to something Bernard said, but it's now 2 in the morning and I've forgotten what he said. So basically, I think at this point, you should write the draft. It seems like everybody's, pretty comfortable with the general approach, and then we can take a look at it and discuss an actual draft.
Great, thanks.
Thank you. And with that, I think we are 1 minute over time, and we have finished our agenda. So thank you, everybody. And I'll see you at other meetings of the IETF, and we'll see you possibly at interim. We will discuss probably the chairs, and we'll discuss on the list whether we want to have an interim, depending on how various work is going. And otherwise, we will see you in San Francisco. And Bernard, anything else to say?
See you on the mailing list.
Yep. And thank you again, Harold, for taking notes and for being our person at the front.
Thank you. The notes are noted.
Thank you.
Was it the SSRC or No, I don't think he answered, but it's my guess for what's